In Lesson 4, students explore how a virus makes a person sick, and they use the practice of modeling to make sense of their ideas. Scientists use models to make predictions, ask questions, and form theories about how or why systems work, and they're a powerful way for students to visualize their thinking and how it changes over time. A model is a set of ideas about how or why something works the way it does. Models can be represented in different ways, such as with physical materials, diagrams, writing, or a computer program. The way a model is represented is not as important as how students use it as a tool for making sense of phenomena. In this lesson, students draw and label initial models to visualize their ideas about how viruses make us sick. Students then conduct research into viruses and how they work, and return to their models to revise their initial thinking based on the evidence they've collected. If you've never used models or modeling before in class, or even if you have, you may be wondering how to support this important practice in this lesson. Let's hear more about that.
We had initial models that helped me to understand what background information they were coming to a lesson or the unit with. And then as they learned, I would see more detail. I would see them starting to draw something like a system. I would see labels. A lot more of the things that we want to see in student modeling would show up throughout the unit. And that really gave evidence to the fact that not only were students gaining content knowledge, but they were gaining the scientific practice of modeling.
Lesson 4 allowed me to kind of do a check-in at a bunch of different levels, on a more individual level and a small group level. And then if there were any inconsistencies or if something didn't really match with the other reading that they had done, I didn't have to address it. By the time they had come to the whole group, the consensus forming came really naturally. We were remote, so doing it on Jamboard was really useful because there are also students who really wanted to represent their thinking, but when writing was more challenging for them, on the Jamboard, they were actually able to insert an image of the coronavirus and duplicate it along the way so they could show how the virus would travel from one person to another. It was a very organic way to synthesize what they had learned and communicate it. And it was really exciting. Like they were really excited to draw digitally. They were really excited to take what they knew and show it in new ways.
Over time, what we do is we don't look for a perfect model at first, but what we do is we use that model to help us mine places where we're vague or we're not sure. And then those become places for us to refine our research. That's a really effective tool because then what we do is we can come back to and create a class consensus model as we move forward, and that becomes like a collection of our learning. And we can even go back and talk to ourselves, remind ourselves, remember when we didn't really understand what happened here, and then we found out more information, and then we were able to fill in the blanks. So I'm a really big fan of using models in science teaching.
There was a lot of new vocabulary in this unit that students didn't have mastery of when we started. And so being able to talk from a model and explain their thinking from a model gave them a way to have their ideas on paper and then point to it. And they were using more vague words like this and that, but it gave us a way, like an on-ramp, to be able to look back at our word wall and then replace that vague language with more specific vocabulary that we had learned. But it also allowed students to still engage in the discussion, whether or not they had the vocabulary at the beginning of the unit.